So I'm Gregory Wrightstone. I'm a geologist. I'm an executive director of the CO2 Coalition. I'll tell you a little bit about that in a moment. Um, uh, again, I was accepted as an expert reviewer for the Intergovernmental Panel on Climate Change. Um, I've written two books. My latest book, the first book was Inconvenient Facts, which was very, I see a couple people nodding their heads. It was probably it's the one of the most successful books on climate change over the last, there we go. Thank you, Rachel. I'd love to have that, sign that for you. My latest book is A Very Convenient Warming, How Modest Warming and More CO2 Are Benefiting Humanity. And so in this book, we've taken another step beyond the first book. We documented that there is no climate crisis, and there isn't. It's very, and Rachel, again, that's a very convenient warming. If you just search for convenient warming, it should pop up. Um, and of we document that there is no climate crisis, and that's categorically, it's easily, if we just look at the science, the facts, and the data that supports that idea. This book, we've taken it a little bit further, and I've pushed that it's clear that not only is there not a climate crisis, but rather just the opposite, that Earth's, by almost every metric we look at, Earth's ecosystems are thriving and prospering, and humanity is benefiting from warming and more CO2. And it's not even close. Huge benefits. And it's what we believe at this is our mantra at the CO2 Coalition, promoting the benefits of carbon dioxide. The CO2 Coalition, just to give you a little background, was formed in 2015. Dr. William Happer is currently our chairman. He was one of the co-founders of that. Um, Currently on our board, we've got, many of you are aware of the name Patrick Moore, I'm sure. Maybe you might have some of his books. He was a co-founder of Greenpeace. I've worked closely with Patrick over the last, in fact, he hired me as executive director here, and I've worked closely with him. He's a true gentleman. Dr. William Happer is our chairman. He's emeritus professor of physics at Princeton. If you follow this idea of climate, fighting back against climate nonsense, you know of William Happer, of Will Happer, probably the most brilliant man I'll ever meet, and humble and a true gentleman in every sense of the word. But again, he's our chairman, Patrick Moore. And we just brought on Dr. John Clauser onto our board, who's the 2022 Nobel laureate. We also have distinguished people. One of the top people we have in the CO2 Coalition is a fellow by the name of David Siegel. You might have heard of him. And so he's a member, all others pale in comparison to David. So, we march in his shadow. But no, thank you, David, for everything. I'm glad we were able to bring you on.
I am the king of asking stupid questions.
Uh, there's there are no stupid questions, David, just stupid people asking them. Okay. Uh, and so we've got this group of, I think we are the undisputed scientists, the top scientific body in the world that's fighting back against this. And we try and stay out of the politics as best we can and stick to the science. Science only. Let the science. I believe the science will win the day. Uh, Others in this arena don't believe so. They think that it'll be economics that will kill this thing. That once prices get to 6 and 8 times what they are today, uh, that it'll fail from that. But I'm a scientist, so I think that's the science. Some of I could probably, maybe we could get me on a different day to go through the whole litany of or I could bring up a presentation. What I brought today was, uh, well, let me just, before we go on here, I'm jumping around. So CO2 Coalition, we went through some of prominent people, but if you go on our website, co2coalition.org, and look at our members, there's most of these are PhDs, just really talented people. And we have most of the bigger names in anti-man-made climate crisis are part of our team, and it's a real honor to work with all of these people. And so I'll just to say to the CO2 Coalition, we've just exploded over the last few years. It's been remarkable. We had 45 members when I took over in 2021. We've got nearly 200 today. Uh, our budget is now tenfold, 10 times it's increased since 2021. People are just responding to our message. And part of it is, I think, is we do just stick to the science. We've now got 14 employees. There were two when I started. It was me and another person. We're up to 14 and we're looking to hire two more. And so what we
Wow.
did with this big budget, we need a bigger budget because I need more people to hire. The more people we hire, we get our message out. Um, and we've got big plans for the future. We can talk too about uh, we've got an education initiative that I'm so proud of. That's the CO2 Learning Center, co2learningcenter.com. And maybe we can talk a little bit about that in just a moment. And after I go through this first presentation. And what am I forgetting about the CO2
I have a
Coalition,
quick
David?
question, Greg. Where does the funding come from? Because people say it's an evil organization funded by oil interests.
I wish we were. We don't. No, we don't. We don't get any of that. But we've got. Uh, I've talked to Will Happer about that, and we both agreed if an oil company wanted to step up and give us a couple 100,000, we would take it. We're being accused of being oil shills every single day,
Right.
but I do know of. We do know we have people in the energy business that are donors as individuals, but that's not a big, those aren't, these are small pocket donations we get from them. Over 99.9% of our donors are individuals. And this is another thing that'll blow you away. Uh, when I took over, we had 145 donors. Today, we're over 13,000. And
Wow.
yeah, and that's from people just they just said, we just love what you're doing. You wouldn't believe the number of people that have stepped up and we get just, they'll send us a very large contribution. We've never heard of them. And we had one last week. And I said, oh my goodness. And he says, you use this as you wish. I trust you. And, I want to support what you're doing. And it's really, really heartening to see these people supporting what we're doing because it allows us to do even more. And so, no,
Phenomenal.
we don't have,
Phenomenal work, Greg. It's just amazing what you've done.
yeah, and it's, I think the next book I write should be how to build a nonprofit corporation or in 18 months or less, because it's really been, I shake my head. We all do about what we've got and some truly remarkable people that work hard and believe in our. And we have one gentleman. I don't. It's. I hope I'm not boring you, but we have one gentleman that showed up about a year and a half ago. Um, Very well known. He's a best-selling author of. He's a consultant to CEOs and CFOs. He's works with some of the top, Dave Thomas of Wendy's, and I won't name the other large corporations you've heard of. And he provides advice to their seed class level people, and he's written books. He was actually for he's quit doing it, but he and his wife were on cruises. He was a motivational speaker that they would provide him. He gets a free cruise, he and his wife, and he was a motivational speaker on the cruises. I'm not sure how you go about doing that, but it was a good gig for a while. And um, and so he just showed up. He says, "I love what you're doing. I'm now partially retired. I've been looking for a nonprofit organization I can help." And he says, "You're the ones." And so he shows up. He works 3 or 4 days a week at our office. He gives me good advice in terms of corporate the inside core, how do we do things? How do you work with people? And man, now with a large staff, he's been really, really helpful. So we've had bizarre things happen for us that are really good. Um, and I do lots of interviews. I did almost 300 interviews in 2023. I've already done three before today. I've got two more after this one. And, I'm going to try and get the message out there. I've got more, I got a big one tomorrow. And in the United States here, it's not so much, I don't think you have it in the UK. Here in the United States, we have a lot of radio stations that do talk radio, and there are thousands of them across the United States. And it's a pretty big thing here. And so one of the stations I'm on tomorrow broadcasts over 285 stations, and so we got a reach across the United States. And I don't think that I'm pretty sure you don't have that in the United Kingdom. It's rather unique. Um, and that I'm just getting a warning here, by the way, from Hillsborough County, Florida, that says, "Get out now or you're going to die." Basically, I know that's what they're calling to tell me, and they've pretty much told everybody in that area that you won't survive if you don't evacuate. We've already done that. Um, and so, what I thought I'd do today, oh yeah, and then, like I say, my new book, it went to number one bestseller over the week. My birthday was Thursday, and I woke up that day of my birthday, and it was number one bestseller on Amazon in the climatology category, which was the first book was quite successful. So I was really happy to see that. Uh, why don't we? Am I able to share here?
Sure, please.
All right. Uh, First, I want to show you. Do you see the screen? Can you see that, David?
Yes, yes.
So I just wanted to share. Uh, this is Hurricane Milton, and I've got the red dot there, and this is what it's supposed to be just before landfall here in a few hours. So this was from earlier today. I think it's moved. It's supposed to hit a little bit further south. So we are. If you can see my mouse, David, can you see that?
Yeah, I see the mouse.
Yes, that's the Wrightstone homestead, and that's the hurricane. And so we're over about here on the east side of Florida. One of the other things they've talked about are that climate change is making hurricanes more numerous and more intense. Well, I took a look at this. These are landfalling hurricanes in the This is Florida data. And the best way to analyze and review long-term hurricanes are by landfalling hurricanes. And that's because we can go back confidently to 1850. So we've got 170 years that we can go back and look at land. This is by decade here, by the way, landfall, because we know every single hurricane that made landfall on the Atlantic or Gulf Coast of the United States. You can't miss them. They're pretty hard to miss. So we know for sure we can, with confidence, that we can go back to 1850. So we see that Florida landfalling hurricanes are in decline, not an increase. And so that should be comforting. It doesn't feel very good right now as I sit here waiting for the hurricane to hit me, but you have to take a dispassionate look at this and look at the data, look at the science. What does it tell us? Put it as a geologist, we want to put these things into the long-term context. And so what I thought I'd do, I'm going to stop sharing here, turn that off, and I'm going to present to you uh, are man-made emissions the primary source of the increase in atmospheric CO2 since the Industrial Revolution? That's the title of it. And no, I'm not going to read everything. That makes for a bad presentation. But again, this was Athens. And so what we found was the evidence is overwhelming that this increase in CO2 is from man's emissions. And we can walk through, we actually looked at 7 different ways that prove, in my mind, or at least are supporting, that it's from man's emissions and not nature. And any one of these should be enough. Uh, Part of it is just common sense, and a lot of it's science. And I think actually the common sense arguments are actually more impactful to me. So let's start looking into this. And can you still, I said my internet is unstable. I'm going to blame it on Hurricane Milton. So we'll simplify this argument. Will adding large amounts of CO2 to the atmosphere increase atmospheric CO2? That's basically what the argument is. If you put a whole bunch of CO2 into the atmosphere, they're saying it's not going to increase atmospheric CO2. Well, this is one of the common sense arguments. Well, of course it will. But we've got to go through, we should end it right there, but we can't. So we have to go through and back it up from science. And let's take a look here. The blue line is carbon dioxide through time going back uh, almost 600 million years. And during I've got the yellow highlighted area is where the coal, most of the coal, a large percentage of the coal in the world was created at this time. It was called the Carboniferous for a good reason. We had vast coal swamps. And you can see that at the beginning of this Carboniferous period, we were at over 4,000 parts per million. And that was the same time where grasses and woody plants evolved at that time. And what we had was large forests being developed in coal swamps. And the key factor here is the woody trees, the plants that make up the coal, uh, they would fall and die, but they didn't rot up because the lignite that was what evolved so the woody plants could grow tall. Think of lignite as rebar in concrete. And the lignite or lignin in the trees would fall, die, and accumulate and not rot up. If it was today, um, we have all sorts of things that feed on those, but at that time there was nothing. It went for 150 million years of accumulation of these swamps, accumulating, getting buried, later converted to coal. And for example, in the United States, the USGS estimates that 83% of the coal in the United States was accumulated during this time. Uh, and then right at the end, during the Permian, you can see where the two arrows are pointing here. Uh, we had a great increase in carbon dioxide. Two things happened at that time. There was finally something developed called white rot fungus. Um, and I don't recall the technical name for it, but it was able to digest uh, this lignin, and they could consume it. Uh, and one of the things I say could contribute to the huge increase in CO2. Uh, Probably the carbon dioxide at that time dropped significantly because it was being taken out of the atmosphere and converted and saved as coal. And it was the old CO2 capture and sequestration, except it was here all naturally sequestering it, and it dropped CO2 levels by almost 4,000 parts per million. And and then at the end of this period, we had two things going on. There were probably hundreds of feet all over the world of trees that all of a sudden started being consumed and their CO2 was released. That may have contributed to the rise, but also the Siberian Traps volcanic event happened, and it also released a lot of CO2. Bear in mind that most volcanoes don't actually produce much CO2. Well, they do for a short period of time, but it pales in comparison uh, to what our emissions are. But these Siberian Traps, there are two types of volcanoes. We have explosive, like Pinatubo, you know what that looks like. And we also have effusive volcanoes like Kilauea, Hawaii. These are just pretty much, Iceland is a lot like it, just flows out. And the Siberian Traps occurred at this time, went for many millions of years of just huge, huge uh, ec- ec- volume of lava that was just coming out, covered most of Siberia, huge area. There was another one in India called the Deccan Traps at a later time. But these are thought to, so whatever, we had a large increase in CO2. But the key here is we had a huge decrease in CO2 because all of that CO2 is being locked up in coal. And so the question I have, um, we're now liberating. We're now liberating the coal. Why, of course, if all that coal creation could reduce CO2 levels by 4,000 parts per million, wouldn't it just make sense that if we're burning that CO2 and liberating the CO2, uh, why could it not increase 150 parts per million in the atmosphere? And so this is the blue line here, of course, is CO2 through 400,000 years. We see that CO2 increases during each of the interglacial warm periods, and we're in one now. And so looking through time, we never got to these levels. So something different is going on right now. Temperature's been driving, and something's different. And that different thing was emissions of fossil fuels. And so the other thing we learned through time is that these 100,000 year cycles of high CO2 and low CO2, uh, we have temperature changed first and CO2 followed after. That was true for hundreds of thousands and millions of years. But it's different now. The past is not the key to the present because something's changed. It's things have changed, and that change is we've got a new source, an entirely new source of CO2 in all of world's history. We have not had anything like this, and it's because of our emissions. We also, at the CO2, we published this paper ahead of the total paper. It was by Renee Hannon, fellow geologist. And we wanted to support that. In this case, we're documenting that ice core measurements of CO2 are what we call the gold standard. And one of the problems we had with some of the people that are promoting natural CO2 is that they're saying that, oh, no, 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 we've had 400 and 500 parts per million in the past. Well, but they're using different types of measurements that really are just not suitable for measuring CO2. And that's because they're measured, it's chemical and stomatal measurements of CO2. And they're compromised because both of those are measuring CO2 um, near vegetation. And vegetation, if you do it, and you can be in the UK or Greece, wherever you're in an area that's highly vegetated and have a CO2 meter, that CO2 meter can vary as much as 200 parts per million between day and night and one day to the next. And so you have to be either high altitude or someplace like Antarctica where there's no vegetation, or Mauna Loa where there's no on top of the peak there. Uh, and so what they're doing is saying, well, we've had 4 and 5. This is nothing unusual. Well, yes, it is. So that 50% is something's different, and that something is fossil fuel life use. Um, so this is really important. If this CO2 level is unprecedented in 800,000 years, well then we've got something new happening. Again, we went through here plants, you're looking at plant stomata data, and you can see that CO2 levels, this was near the solid line is near the ground, and you can see there's huge variation. And over here, Dr. Happer reported that he's measured at Princeton University, just outside his home there. He said it got as low as 300 parts per million at 3 in the afternoon, and as high as 550 parts per million at dawn. And so we see this great variation of CO2 night and day. Um, Plant stomata also have high uncertainties. That's one way that people can measure it. And chemical measurements are also bad. I won't go into the details of each of these. So we had 6 lines. That's kind of common sense that we've looked through. 6 lines of evidence confirming nature. Now, nature being the oceans, or the two carbon sinks are the oceans and the biota, the plants on Earth. And uh, so we'll look at first the mass balance to show that human emissions are the blue line. The red line is atmospheric CO2. And looking at this, CO2 parts per million per year, going back to 1960, we have pretty good documentation of each. And you can see we're emitting twice as much, almost around twice as much CO2 as what's showing up in the atmosphere. So what's that tell you? We're emitting twice as much CO2 as what we're able to measure in the atmosphere. What does that tell us? It tells us that something is a huge sink that's taking half of that new CO2 uh, out of the atmosphere. And this is by itself should be conclusive. This is called the mass carbon balance. You have to be able to explain how can we emit that much CO2 and have it not and have the nature is a huge sink, and it's mostly increase in vegetation that's increasing, it's taking that CO2 out of the atmosphere, and some in the oceans as well. So nature is more sink than source, going back to 1960. Um, I'm not an expert. Some of the others that are much smarter than I came, we've got a team effort here, but uh, carbon isotope of C13 to C12 ratios, um, it indicates that burning of fossil fuels produces lighter numbers of that ratio. But C13, C12 ratio can't distinguish between vegetation and fossil fuels if they're but it does indicate we can use this to say it's not coming from the ocean using C13, C12 ratios. Again, I'm not going to go into all the details here because um, number one, I'm not an expert on it uh, as detailed, but it's our paper, David, when we get it out, you can probably pass it around to your guests that detail this in some uh, detail. And the other thing is the C14, C12 ratio. C14 um, is the carbon isotope that's it's used for radiocarbon dating. And so what we have is uh, emergency alert, extreme tornado warning. Okay. I'll be getting these throughout our talk here, but it'll keep you on the edge of your seat. You don't know if Greg's going to survive the talk. Let's hope I do. And so these are radioactive. This is a radioactive isotope, and it's got a half-life of around 5,300 years. And so this is really important that C14 is created uh, in the upper atmosphere and naturally, but there was a huge spike going in the 1950s because we had atmospheric atomic bombs that put off. So we got a large amount of C14 in the atmosphere. And that's that spike we see there. But the interesting thing, since coal, oil, and natural gas are all millions of years old, we can't take carbon dating back more than 50,000 or 60,000 years because the half-life of C14 keeps declining. So there's once you get to 60,000 years, it's below our ability to measure it. And so now we've got millions of year old data. And so any carbon dioxide from fossil fuels has zero C14. And so what we're seeing is this great decline, a significant decline in C14 in the atmosphere. And that's because it's being diluted by burning of fossil fuels. That again, this should be pretty conclusive that it's not from plants, that uh, it's from the burning of fossil fuels. We also have declining oxygen concentrations. Uh, and a lot of you probably have, maybe even David doesn't know about all these things and how we can tie it back to this, but burning methane uh, yields, methane is CH4. It's the simplest fossil fuel. And burning one molecule of CH4, it creates heat. It combines with oxygen, uses two oxygen uh, uh, atoms to create two molecules of water and one molecule of CO2. So what they're doing is burning methane. What we're seeing here is we're burning more methane than is being sucked up by the plants. And because of that, oxygen levels are being consumed by the burning of fossil fuels. Now, it's nothing to be alarmed about, but there is a measurable decline in oxygen levels. Again, pointing to uh, fossil fuels being the source of our CO2. So this proves that CO2 uptake exceeds plant decay. And that way we've looked at oceans can't be the source of it. And now the biosphere has to be a net absorber of CO2, not a net. Um, yeah, so if the burning of fossil fuels can cause a decrease in atmospheric oxygen, why could it not also fuel an increase in CO2? We also look, you've all have heard of ocean acidification, and that's an increase. What we see here is that increasing CO2 is absorbed, some of the CO2 is absorbed by the oceans. And when we absorb CO2, it has an increasing decline, a slight decline in pH. Uh, another class we could have here is relating ocean, what they call ocean acidification, which is really misnamed. Uh, and what they do, and so as we increase CO2, there has been a very slight decrease from 8.1 pH to just slightly less. And bear in mind, anything above 7 is basic or alkaline. Anything below 7 is acidic. Uh, and so the pH of the oceans have decreased about 1/10 of a pH since the start of the Industrial Revolution. The keynote here is uh, the keynote here is that the oceans are well buffered, and we're going to have another paper coming out on that. And we've got a wonderful lesson plan for the children detailing how we can look into this. And what we find is that if you take fresh water, you can turn it acid by providing huge amounts of CO2. You can put bicarbonate tablets into a bucket, and you can make fresh water and distilled water acidic pretty quickly. But you can't do it with ocean water because of all the buffers that are in ocean water. And a lot of those are bicarbonates, and there's various things uh, that we see in ocean water. And you cannot make ocean water with all the buffering. About the lowest you can get for pH is about 7.9 pH, which is still firmly alkaline. Um, just to conclude here, uh, the atmospheric concentration of 420 parts per million, significantly higher than in the past 800,000 years. Something's different. The emissions of CO2 are much larger than the increase that's showing up in the atmosphere. So nature is a net sink for CO2 and thus cannot be a net source. And so we've jumped through all these hoops. We've looked at 7 different lines of evidence showing that um, that the increase of atmospheric CO2 is from our burning of fossil fuels. And I'm okay with that because David and I believe, as do every single one of our 200 members, that the increase, more CO2 is hugely beneficial uh, to humanity, to vegetation, to agriculture. And so we believe that more CO2 is much better. And my wife just opened the door. She's looking pretty nasty out there. And so there are tornadoes all around us here. So um, and I think I'm done. Let me stop sharing.
Excellent.
And
Thank you very much, Greg. You
let's go
had
get
me
in.
at mass balance.
Yeah, yeah.
Bec-
That alone. How do
Yeah,
you?
that alone, and that's what Javier says, and Javier's word has a lot of weight with me.